This is picking up where we left off yesterday. You can add or subtract. You can also multiply and divide in the elimination method, but for now we're learning about adding and subtracting still. The equations to eliminate one variable and then solve for the other variable. So you substitute the value. Once you've done that, you substitute the value into either original equation to find the value of the eliminated variable. And then you write the solution as an ordered pair, which is the point x, y, and there you go. So if we have x plus y equal to 0, and then minus x minus y equal to 0, what happens when I add them together? Well, you get 0 minus 0 equals 0. That's definitely true, but this is going to do something a little bit differently, because it doesn't matter what x or y is. X or y could be anything. That winds up where there are an infinite amount of solutions. Infinite solutions. You can't write this as an ordered pair, because literally any numbers you pick for x and y will work. And you might be wondering, well, why is that the case? Well, these are actually the same line. That's why that's the case. If I take this one and subtract x from both sides, I get y is equal to negative x. And if I take this one and add y to both sides, I get y is equal to negative x. So as you can see, they're actually both the same line. And when you have a line and draw another line on top of it, then of course any point you pick will satisfy, will I guess be a solution to the linear system. So let's do this one now. If we have ax minus by equals c, and then you have ax minus by equals c, right? You're going to have to make one of them negative, so if I multiply everything by a -1, all the signs will flip. You'll get the same thing, 0 plus 0 equals 0. So this is basically the same example as the other. Infinite solutions. So now I want to go back a page and cover these examples, which we didn't get to from the day before. And this is on your previous page of guided notes. 4x minus y equals 3. 4x minus y equals -2. In order for them to add together, I need to be able to eliminate the y variable. The only way I can do that is if one of them is the opposite sign. So multiply one of them by a -1. You're going to get negative 4x plus y is equal to 2. And now that I've done that, I can now add these two things together. Positive 4, negative 4, 0. Negative y, positive y, 0. 3 plus 2 is 5. So 0 is equal to 5. This statement, though, isn't true, right? It's not true. So that means that this particular linear system has no solution. And why might that be? Well, this is probably a pair of parallel lines. And if you're looking for the point at which parallel lines intersect, you'll be looking forever, because they never intersect. So that's why this particular system, when you try to work it out, has no solution, or at least you get this nonsensical gibberish where 0 is equal to 5, and that's not true. So let's solve this other example. We have 3x plus 2y is equal to 5. And then x plus 2y is equal to negative 1. So I would need this y to be negative. So I can do that pretty simply by just multiplying everything in this equation by negative 1. All the signs will flip. Minus 2y is equal to a positive 1. Now I can scratch this out, add them together. 3 minus 1, 2x. Plus 2 minus 2, 0. 2x is equal to 5 plus 1, which is 6. That makes x not equal to 6. X is equal to 3. Right? Because you have to divide both sides by 2. If x is equal to 3, and I have this equation like x plus 2y is equal to negative 1, right? This is one of the original equations. Then 3 plus 2y is equal to negative 1 because I substituted x for what x equals. It equals 3. Now 3 plus 2y is equal to negative 1. Now I have to do some opposite bruh. That makes 2y equal to negative 4. And negative 4 divided by 2 is a negative 2. So this is the ordered pair 3, negative 2. That's the point at which these two lines intersect. So this example, if I have 2x plus 5y equals negative 24, and 3x minus 5y equals 14. Oh, nice. I don't have to do anything to these to get the y's to eliminate. Add them together. 5x equals negative 24 and positive 14. That's a negative 10. Divide by 5. X is equal to negative 2. Now that I know that x is a negative 2, let me substitute it into one of the original equations. How about this one? 3 times a negative 2 minus 5y equals 14. 3 times negative 2 is negative 6. Negative 6 minus 5y is equal to 14. What happens when I add 6 to both sides? I get negative 5y. It's equal to 20, which makes y equal to a negative 4. So then this is the point negative 2, negative 4. And then these last two examples, if I have x plus 2y, I'm going to write this other one right below it. 4x minus 2y equals 12. Right? Look at there. Really easy to eliminate. Positive 2y, negative 2y. If I add them together, I get 5x is equal to 20. Divide both sides by 5. X is equal to 4. If x is equal to 4, and I know x plus 2y equals 8, well then 4 plus 2y equals 8. Subtract 4 from both sides. You're going to get 2y is equal to 4. Divide by 2. Y is equal to 2. 4, 2. So I know it's quite a bit of steps, but I'll also be around to help you. And please be sure to ask questions, and I can help guide you through how to figure these out. These are no different than the homework examples, and we'll go from there.